Okay, so back to graphing. So now we're going to graph reciprocal functions. And what do we mean by that? We mean the variables in the denominator. This is a special situation. So way back, I don't remember what chapter it was in our new course here, but we tried to figure out whether things were linear, quadratic, polynomial, and whether they were just an equation or a function. Well, I kind of said back then, generally speaking, this is the situation, and it is. But when you start putting variables in the denominator, things become a little bit different. And this is a different situation. There's another way to write these, but for right now, because we're dealing with reciprocals, it's in this section. And so what we have is y equals 1 over x. That's just a general pattern. So for reciprocal functions such as y equals 1 over x, there are values of the independent variable that result in division by 0. Right? You can end up with division by 0. And as we know, division by 0 is infinity, or some like to say undefined. You can't have it. And therefore, you have values that are non-usable, right? And therefore, these values form vertical, use the word asymptote again, A-S-Y-M-P-T-O-T-E, A-S-Y-M-P-T-O-T-E. These values form vertical asymptotes. And what are those asymptotes? Values that the function approaches but never reaches. Values that the function approaches but never reaches. So in the example up above, x cannot be 0, right? So there is no domain value of 0, right? 0 is not part of the domain. If you were listing the domain for this function, you'd have to say the set of all x's, but x cannot equal 0. It's everything else except for 0. That's the idea, and that's the situation. Let's take a look at the graph. Move this higher for you. So let's graph y equals 1 over x. All right, so you got an asymptote of x equals 0. You also have another asymptote of y equals 0. You actually have two of them. So I'm going to take my green, and at y equals 0, which is right along the x-axis, I'm going to put a line there for y equals 0. I know that doesn't show up that great, but that's where it is. Okay. The intersection of the asymptotes is the center. And we haven't talked about this shape yet, but this shape is a hyperbola. And a hyperbola, H-Y-P-E-R-B-O-L-A, a hyperbola. I don't know if you guys got this far in geometry, but in geometry you do deal with conics, which means you deal with ellipses, circles, hyperbolas. Did you guys get that far? Did you talk about hyperbolas? Okay. I know it's pretty far in the course. And it's not all that clear, but out of a conic section, you can get all the different shapes. You can cut it with a horizontal slice, and you get a circle. With an angle slice, you get an ellipse. If you slice off the angle but not going past the center, you get a hyperbola. It's just the possibilities are a parabola, and then you can also get a hyperbola if you go perpendicular. All right, those are the aspects, not a big deal. I don't have time to deal with it in this course. Geometry, if we get there, the end of Algebra 2, and I believe you'll get it next year in advanced math, those of you that take it. All right, so let's take a look at the graph. What is a hyperbola? What does this thing look like? We can graph it. All right, we know that x can't be 0, and we know that y can't be 0. Those are two things that cannot happen. I'm just going to do a simple xy chart. All right, so if you put -4 in for the x, then you get y equals -1/4. So when the x is -4, the y is -1/4. So somewhere about right there, just go a little bit below the x-axis, right, 1/4. All right, if x is -2, then y is -1/2. So at -2, go down to -1/2. Not much more further below. Again, you guys understand each time putting this value in for the x, right? So if x is -1, then y is -1, so we get the point -1, -1. When x is -1/4, then 1 over a -1/4 is a -4. So 1 is -4. If x is 0, that's infinity. I just threw that in there to make sure you understand the asymptote. Right, 1 over 0. If x is 1/4, 1 over 1/4 is 4. What did I just do? All right, hold on. Let's see, -1/4. Oh, I'm in the wrong place. No wonder. Come on, Kool-Aid drinkers. Help me out here. -1/4 on the x is all the way down to 4. I should have been on this side. Hopefully you agree. -1/4 x down to 4 on the y. So right here, -1/4 and -4 is about right there. Then we hit the asymptote, and now I'm on the other side of the asymptote. So +1/4 is up to 4, excuse me. +1/4 is up to 4. +1/4, 4. 1 over 1 is 1, so 1 is 1. If I do 2, 1 over 2 is 1/2. So 2 on the x and 1/2. And one more there. If I use 4, you get 1/4. You can see that these are mirror images. So here's the hyperbola. It approaches there, it comes through, and it sweeps down like that, arrows on both ends. And this is the mirror image, kind of reflected, goes down like that. Both halves make up one hyperbola. If we get there, I don't know that we're going to make it either in this course. It's like the last chapter. If you get there, there are aspects of foci. There are 2 focuses on these, and there's formulas to figure out where they are. Again, the center on this thing is the point 0, 0, right? That's the center of everything, and let me use purple so it stands out. That's the center of the hyperbola, although that point doesn't belong to either of them. It's just simply the center. It's not a point that solves. It's simply the center. So both halves is one hyperbola. Right? All of it together is one hyperbola. Luke.
How do you know the estimates of y is 0?
I'll show you in a minute. But the quick way is I could just as easily stick x up there and y down there, right? At which case y now cannot be 0. So that's one way of looking at it, Luke, and you can always do that, but I'll show you another way here in a moment. Okay? A little bit more simplistic way, but that's the reasoning. You can swap the x and the y ends up on the bottom. Okay, let's do a couple things here. All right, so now we got to deal with transformations. And look, we've done transformations before. And we know about A values and H value and K values. So down at the bottom where I have x minus, what should I stick down there with the x minus? H, because math goes together. And just like always, it's x minus h. And therefore, after the green plus sign, I'm going to stick K, because math is nice and orderly. And sure enough, there's the horizontal shift and the vertical shift. Again, the A value is going to determine how steep or how, what was the other word they used? Flat, yeah. I used narrow, they used flat. All right. A bunch of flat earthers. All right, so what is the center of the hyperbola? HK, right? The center is HK. But not only that, there's a vertical asymptote at x equal h and a horizontal asymptote at y equals k. So Luke, that's the easy way to figure out the asymptotes. Figure out the center point, and now you got an asymptote, vertical and horizontal, at that center point. Okay? All right, and the graph is said to have discontinuity. D-I-S-C-O-N-T-I-N-U-T-Y, discontinuity. Discontinuity. D-I-S-C-O-N-T-I-N-T-U-I-T-Y. Is that what I got in there? Yeah, T-U-I-T-Y. Discontinuity at x equals h. All right. What is discontinuity? Let me show you with the graph up here. Can the x value be 0? Is there any y value for an x value of 0? And the answer is no. Does the graph continue? Can you put your pen down on the paper and continuously draw the whole hyperbola? And the answer is no. You have to take your pen off the paper and start over again. There's discontinuity. It discontinues at x equals 0. Right? There's no way, they don't connect. And it doesn't have to be a hyperbola. It could be any kind of graph that doesn't connect. If there's any in-between values that don't exist, there's discontinuity. That's all that means. It just doesn't connect. So there's discontinuity at x equals h. The a value, if the absolute value of a is greater than 1, then the graph is stretched. If the absolute value of a is less than 1, it's compressed. That's not a big deal. If you just let the numbers do their thing, you'll see that, and you'll figure that out. You just let the things do its thing. And then, again, if negative a, then it's reflected about the x-axis. But, again, you got to be careful here because it's really reflected about y equals k, that horizontal asymptote. So, quote-unquote, x-axis, that's if there's no vertical shift. If there's a vertical shift, it's about y equals k. All right. I hope all that doesn't leave you feeling, like you're lost already, because these are all things we've done already, right? H and k we've done, horizontal shift, vertical shift. A value we've dealt with parabolas. And so we're just applying those same principles. So it's going to boil down to, one, when you look at something like this, where the variable's in the denominator, you should automatically expect a hyperbola. Expect that shape. By expecting that shape, you're going to know you're going to have two sides. And you got to expect that. And then the rest is X and Y chart, center point, and asymptote. So let's go ahead and graph. So you look at D. First thing you should do, like you should in all these, is determine the center point, right? And so hopefully you say, oh, okay, the center point of this is at, so the center point is at -1, 2. Because again, just like always, an x plus 1 means it must be x minus a -1, right, Destiny? All right, everybody's okay with that. Again, this is all stuff we've done already, and I don't really have time to keep going over things we've already learned. Okay, so that's the center point. So let's go ahead and mark that, -1, 2. Right there is our center point. So look, that's where your asymptotes are, right? Right here. and right here. You need those. We need our asymptotes if we're going to graph this thing properly. Is that okay with everybody? So you can all do that. Everybody in here, that you should have no problem with that. We already know H and K. Mark the center point and draw your asymptotes. Okay. Now we know we're going to have a left and a right side to the hyperbola. So from here on out, it's XY chop. And you got to start, hey, either left of the vertical asymptote or right of the vertical asymptote. I like to do the left side first. You can do the right first. It doesn't really matter. But look, can X be -1? No. So I'm going to start at -2. At least that's the way I do it. Start at -2. Now we don't have time to show this every single time, but so what am I doing? I'm putting -2 in for X. Again, it's just elementary stuff. We know how to input values, right? So what do you get? 1 over -1. So that's a -1 plus 2 is a 1. So we get -2, 1 right there. Okay, I know where that curve's going to be, right? But I need a few more values. I go -3. I get 1 over -2, which is a -1/2, plus a 2 is a 1.5, 3/2, right? Can you do that in your head? If you can't do it in your head, then just mark it off. 1 over -3 leaves me a 1. -3 plus 1, 1 over -2, which is a -1/2. -1/2 and a +2 is a +1.5. All right. If you can't think that through, use your calculator. It's right there. And if I go through and do -4, now I have a 1 over -3, which is -1/3. So now I have a 1 2/3. And you see how I'm getting closer and closer to the asymptote, right? Now, honestly, on these, you could do -1.5 in your calculator if you just want to be sure, but generally we're just going to draw it, right? We know we're approaching that asymptote. But feel free to do -1.5 in your calculator and just punch it out in the calculator. But we know the shape, right? We know the shape of this thing. We know it's going to approach this asymptote, and we can already see from these 3 points it's approaching that asymptote. And now I got to do the other side, right? So I'm already at -1, so I'm going to go 0. 1 over 1 is 1. 1 plus 2 is 3. You get 0, 3. Right there. If I use 1, 1 over 2 is a half. A half and 2 is 2.5. I'm at 1, 2.5. You can see we're mirroring the other side. 2 on the bottom. 1 plus 2 plus 1 is 3, so I get 1/3. 1/3 and 2 is 2 1/3. So 2 is 2 1/3, and you see how we're exactly the same thing on the other side. And again, if you want to use -0.5, just punch it out in your calculator. But that's the shape, right? We know what we're expecting, and we got a nice hyperbola. Stuff we can do. It's just XY chart stuff. I know some of you still feel fractionally challenged. I just got to tell you one thing. Get over it. All right? Get over your fractions. Time to grow up. Be a big boy or big girl. You can do fractions. All right, so you look at something like this. So what's the first thing you can do? You come up against another one. You're going to do what? Center point. You got to do the center point. And the center point is 0, 1. Got to do the center point. So mark off your center point, which allows you to mark off your asymptotes. Oops, wrong place on that one. Get it up where it is. Right, there are your asymptotes. Where do you go from here? XY chart. But please, you got to start with your center point, your asymptotes. So look, where am I at now? The asymptote's at 0, so I'm going to start -1, right? -2 over -1 is a positive 2, positive 2, and 1 is positive 3. -1, 3. Whoa! This one's above on the left-hand side. The other one was below on the left-hand side. Why is that? Because the negative, right? The negative A, right? It's mirrored. All right, -2 gives you a positive 1 plus 1 is a 2, so -2 is 1. I'm sorry, -2 is 2. And I'll do one more. -3 is a positive 2/3, so we're at 1 2/3. -3, 1 2/3. Do you see the shape already being you're expecting it? Do you see it? So, all right, that's enough to draw it, because we're technically just sketching this thing anyhow. Right? And it's going to be right there. And we're expecting that mirror image on the other side, right? Go across the asymptote. If you use a 1, you get -2 plus 1, that's a -1. So you got 1, -1. All right, just what you would expect. We're down below. Notice how they're always catty corner, right? Diagonal. Put in a 2. -2 over 2 is a -1. -1 and 1 is 0. So we're at 2, 0. And where do you think 3 is going to be? -2/3 and 1 is a positive 1/3. And sure enough, we're at that mirror image. Like that, right? Clunk. Is that okay with everybody? What's the key? Knowing the shape. What's the key? Center point with the asymptotes. That's the key. Got to expect the shape. You got to start with the center point and the asymptotes. If you do that, it's just XY chart. And of course, some fractionally challenged issues. All right. Don't have time to finish this one, but let's start it. So again, go ahead and name the center point. And just draw your asymptotes. The rest would be an XY chart. So I hope you considered a half 0. Just to help a few of you that aren't quite sure what's going on, if you're going to figure this thing out, you're going to have to change the form, right? And this is just like a 2x minus 1 equals 0 and x equals a 1/2. That'll give you the asymptote when it's not obvious like that. It's the same concept. So you got 1/2, 0. So again, first thing I would do is plot that center point at 1/2, 0. I would then show my asymptotes. And then I would use an XY chart. And just to sketch it, it ends up in here. And it ends up in there. A little bit over to the left. Gotta move both, huh? Who cares? Right? Something like that. And again, you would do an XY chart. I'm just, time's sake. Now that one, the fraction's a little bit more of a pain. Hey, you do have a calculator. Is it okay if it gives you the answer in decimals? Sure. It doesn't matter if your XY chart's in decimals. Matter of fact, you probably graph better in decimals anyhow. Right? If you get a 0.3, you know where 0.3 is. If you get a -2.4, you know where to stick that. So it's fine if you have decimals, right? Not an issue. You guys are very, very quiet. That's not good. All right, so here's one last one. This is a little odd in looking at it, right? So you just got to be careful on your center point. So what would you think the center point is? The K is definitely 0. All right, no problem with the K. What is the value of H? Think about it for a second. What is the value of H? Anybody want to go for it? Value of H. Josh? -1? Agree? How many agree -1? How many disagree? What do you all disagreeers want? 1. Yeah, it is 1. Again, if you do the same thing, if you just set this equal to 0 and solve it, you'll get x equal 1. So if you're ever not sure, just set it equal to 0 and solve it. Remember, you're finding the value of the denominator that makes the denominator 0, right? So set the thing equal to 0 and solve for the variable. So it's 1, 0. So at 1, 0, we got an asymptote. And again, from here on out, it's going to be an XY chart. And I think I got 3 minutes. 3 minutes. See what you can do in these next 3 minutes. Finish it out. If you get stuck, you can look up. Try not to if you don't need it. Oh, you know what? Everybody pause for a second. I'm going to do one more thing. Everybody pause and look up here. Lest I leave you guys with figuring out yourself. If they ask you for the domain, you're going to say the set of all x's such that x does not equal 1. That's how you're going to say that, right? Because it's every value except 1, right? The vertical asymptote. And then the range would be the set of all y's such that y does not equal 0. Right? Because it's all the y values except for 0. Does it make sense? Domain and range? Okay. So I think a few of the homeworks ask you that. Right? And that would have been your look there, XY chart. You're just finishing these off with an XY chart. Key is center point. Is the center point a literal value of the function? No, it's just a theoretical point that allows you to understand the function. All right. Hey, quiz tomorrow because it is Wednesday. Quiz mañana. Quiz mañana. Have a great day in the neighborhood.